okay, now let's move towards another set of programs. And it is this one. अब यो नेगेटिभ नम्बरबाट आएको छ, सिम्पल छ यो पनि, -20, -15, -10 छ, त्यसपछि आउँछ -5 छ। अनि यो सिरिज चाहिँ अब हामीले प्रिन्ट गरौँ अप टु दि ल 11 टर्मसम्म चाहिँ प्रिन्ट गरौँ यो सिरिजलाई। अब यो सिरिजमा हेर्ने हो भने के छ त भन्दाखेरि अब हाम्रो स्टार्टिङ नम्बर छ तर एन्ड नम्बर चाहिँ छैन, ठीक छ। त्यसैले हामी के गर्छौँ, एउटा एक्स्ट्रा भेरिएबल युज गर्छौँ र त्यो एक्स्ट्रा भेरिएबलमा चाहिँ हामी के गर्छौँ त भन्दाखेरि त्यसमा चाहिँ यो स्टार्टिङ नम्बरलाई चाहिँ प्रिन्ट स्टोर गरेर राखेँ मैले। अब एभ्री टाइम हाम्रो के भइरहेछ त भन्दाखेरि यहाँनिर 5 को डिफरेन्स छ। 5 को डिफरेन्स कस्तो छ त, 5 को डिफरेन्स भन्नाले 5 जोड्दै गइरहेछ। -20 मा 5 जोड्यो भने -15 आउँछ। यसमा हामीले अब 5 जोड्यो भने कति आउँछ त -10 आउँछ। -10 मा 5 जोड्यो भने कति आउँछ त -5 आउँछ। नेक्स्ट टाइम भनेको -5 मा 5 जोड्यो भने 0 आउँछ। त्यसमा फेरि 5 जोड्यो भने अनि 5 10 15 20 हुँदै हुँदै कतिसम्म जान्छ त 11 टर्मसम्म जान्छ। अब हामीले फर्स्ट नम्बर हाम्रो a भन्ने भेरिएबलमा स्टोर गरिसकेका छौँ। अब हामी लुप क्रिएट गरौँ। आवर लुप हैज टु रन 11 टाइम्स, सो 1 to 11 यो भइहाल्यो। अब हामीले प्रिन्ट गर्नु पर्यो। अब प्रिन्ट गर्नलाई अब के गर्छौँ त हामीले a भन्ने भेरिएबल युज गरेका छौँ र हाम्रो फर्स्ट नम्बर -20 a मा स्टोर गरेका छौँ। यसलाई प्रिन्ट गरिदिउँ। ओके, हामीले फर्स्ट नम्बर प्रिन्ट गर्यो। अब नेक्स्ट टाइम a मा कति हुनु पर्यो त भन्दाखेरि -15 र -15 हुनलाई a लाई के गर्नु पर्यो 5 ले जोड्नु पर्यो र एभ्री टाइम 5 ले जोड्दै गइरहेछ। सो a इज इक्वल्स टु a मा के गर्नु पर्यो 5 ले जोड्नु पर्यो। 5 ले जोडेपछि यो के हुँदैछ त -20 + 5 कति हुने भयो -15, -15 र 5 जोड्यो भने -10 एन्ड सो अन। इट विल कन्टिन्यू अप टु दि 11th टर्म एन्ड दिस इज द आउटपुट। 0 5 10 15 20 25 30 यो चाहिँ हाम्रो के हो 11 टर्मसम्म चाहिँ यसरी डिस्प्ले हुने भयो। भूमिका क्लियर छ यो?
यस सर।
ओके, अब यही प्रोग्राममा चाहिँ के छ त भन्दाखेरि अब फर्स्ट टर्म पनि थाहा थियो, मानिलिउँ हामीलाई लास्ट टर्म पनि थाहा थियो अरे। फर्स्ट टर्म पनि लास्ट टर्म पनि थाहा थियो। अब लास्ट टर्म कति हुन आउँछ त -30। अब जस्तै म्याथमेटिकल क्यालकुलेसन गरेर 30 भन्ने थाहा भयो भने चाहिँ यसलाई के पनि गर्न सकिन्छ त भन्दाखेरि यो यसरी चाहिँ यस्तो बेला चाहिँ हामीले फर्स्ट टर्म लास्ट टर्म पनि थाहाको अवस्थामा यो एक्स्ट्रा भेरिएबल युज गर्नु परेन। हामी के गर्छौँ त भन्दाखेरि वी स्टार्ट विथ आवर फर्स्ट, द्याट इज हाम्रो स्टार्टिङ नम्बर चाहिँ हामी स्टार्ट भ्याल्यु बनाउँछौँ र त्यसपछि हाम्रो एन्डिङ लास्ट नम्बर चाहिँ हामी एन्ड भ्याल्यु बनाउँछौँ। अब यसमा इन्क्रिमेन्ट कतिको भइरहेछ 5, त्यसैले स्टेप हामी कति लेख्छौँ 5। यसरी गर्दा पनि हुन्छ। अब यहाँनिर चाहिँ अब हामीले के प्रिन्ट गर्नु पर्यो, लुप भेरिएबललाई प्रिन्ट गर्नु पर्यो विच इज I, बिकज -20 -15 अल दोज भ्याल्युज विल बी स्टोर्ड इन I। यसरी यसलाई हामीले रन गर्दा पनि भयो। यसरी पनि गर्न सकिन्छ यदि हामीले लास्ट टर्म क्यालकुलेट गर्न सक्छौँ भने। ओके, त्यसपछि अब मुभ हौँ अर्को सिरिजमा र अर्को सिरिज पनि सिम्पल छ र यो अर्को सिरिज चाहिँ अहिले मैले भनेको कुराहरूसँग अलि मिल्न खोज्छ यो। त्यो चाहिँ के छ त भन्दाखेरि 90 छ, त्यसपछि 80 छ, त्यसपछि 70 छ, त्यसपछि 60 छ, त्यसपछि 50 छ, अनि यो हुँदा हुँदा कतिसम्म गएको छ त भन्दाखेरि 10 सम्म गएको छ। अब यसमा चाहिँ के छ त भन्दाखेरि अब 90 80 70 60 50 हुँदा हुँदै कतिसम्म गयो 10 सम्म गयो। अब यसमा हामीलाई स्टार्टिङ नम्बर पनि थाहा छ 90 र लास्ट नम्बर पनि थाहा छ 10 र यो सिरिजमा चाहिँ यो कसरी फर्म भइरहेछ त यो सबै 10 को डिफरेन्समा चाहिँ यो सिरिज फर्म भइरहेछ। 10 ले घट्दै गइरहेछ। ओके, यस्तो केसमा चाहिँ के गर्न सक्छौँ हामीले सिधै लेख्न सक्छौँ 90 र हाम्रो एन्ड भ्याल्यु हाम्रो लास्ट नम्बर द्याट इज 10। अब 10 ले घट्दै गइरहेछ त्यसैले 10 ले घटाउनु पर्यो। सो -10 हामीले प्रिन्ट गर्ने हो लुपकै भेरिएबल। So let's run it, we get our required output. Let's move towards another set of series, and this series is like this. It is this one 4, then we have 0.4, then we have 0.04, then we have 0.004. Okay, we have 0.0004, then we have again 0.00004. Okay, now this is the, now in between there is comma, but I haven't written comma. Okay. So okay, this is the series. Now this series at first glance it looks complicated. Okay, this series, but it is not that much complicated. So if we just look at this series now, if we start taking the difference, then we won't be anywhere. Okay, we will be lost if we start taking the difference in this particular series. So we have to think in another way. So at the beginning we have number 4. Okay, now let me first do this over here. Okay, we have this number, that is 4, we have zero point 0.4, we have 0.04, and we have 0.004, and so on. Okay, so at the beginning what we will do is we will store the first value in variable a. So 4 is stored. Now next time value of a has to be 0.4. So how can we get 0.4? For this, what we will do is we will divide this 4 by 10. So whenever we divide 4 by 10, what we get is we get 0 is 0, point 0, 10 4 are 40. So what we get is we get 0.4, which is this number. Now next time what we'll do is we can divide the same number. Okay, we can divide this same number by 10, and if we divide this same number by 10, then we'll get 0.04. If we divide this number by 10, then we get this. So over here in this particular program, what we are seeing is it is not the difference, but it is the division. That is, from here, if we want to get this number, then what we have to do is we have to divide by 10. When 4 is divided by 10, we get this number. When again 0.4 is divided by 10, we get this number. Further, if we divide this number by 10, then we get 0.04. Now further, if you divide this by 10, then you will get 0.0004. Okay, this is how it will continue. So this is how this series is being generated. Now before, in our previous programs, there was the difference of 2, sometimes there was the difference of 5, sometimes we had to decrease, and every time the decrement was done by 5, but this time we have to divide by 10. And this division is a normal division. As we already saw, we need all the quotient part. So let's see how we can do this in our editor. So this time we have to divide by 10. So at the beginning, what we'll do is, okay, a is equals to 4. Now print a means 4 is displayed. Now what we have to do is we have to divide this a, that is 4, by 10, and we have to store the quotient in variable a, in the same variable. So this time our division is going to change. It is going to be this division. Before it was this. This is a integer division, whereas this division which we are doing is a normal division. So let's see the output, and as you can see, we are seeing this up to the 5th term. Now suppose, okay, uh, now 1 2 3 4 5 6. Now this is up to the 6th term. So let's do it. Let's increase our loop by 1. That is, let's write 6. That is, our loop will run 6 times. Now let's run our program, and we get this. Now if we trace this program, then this is what we'll see. Okay, so let's see how this is output is being generated. So a at the beginning is 4, I is 1, valid number. So at the beginning we have 4. 4 will be displayed by this line. Now next time, a when divided by 10, we get 0.4. That is 0.4 as sorry, 0.4, it will not be here, but it will be stored in this variable a, that is 0.4. 0.4 will be stored in a. Next will take us to a step. I will increase, I becomes 2. 2 is also a valid number. Then we'll come to this line, print a. Print a means it will print 0.4. Now we come to this statement where 0.4 is divided by 10, and when you divide 0.4 by 10, you get 0.04. So 0.04 will be stored in this variable a. So we have new value in a, which is 0.04. Next will take us to step. I will increase, I becomes 3. I becomes 3. 3 is a valid number, it will display, it will come to this line, print A means it will display 0.04, and so on. It will continue up to the sixth term, and we see this as our output. Okay, Bhumika, anything you would like to ask so far?
No, sir.
Okay, so what should we do? Shall we move into the another set of programs?
Yes, sir.
Okay, now our another set of programs is this one, which is 1. Then we have 0.3. We have, okay, now, okay, before moving into our next program, okay, let me talk about this part as well. 4, that is 0.4, 0.04. Okay, yeah, this was our previous program. So now that this is one way of doing, okay, this is one way of doing this program. Now there is another method also, okay, with which we can do. Now another method, it's something like this. Okay, this is one way of doing. Okay, so another method, it will be like this. Now for 4, okay, 4 when divided by 1, 4 when divided by 1, what do you get? You get 4. That is quite simple enough. When divided by 1, we get 4. So 1 also can be written like this, 10 to the power 0. Just pay attention. That is 10 to the power 0 is 1, and we are dividing 4 by 1, which will give 4. Now for 0.4. Okay, for 0.4, what we have to do is we have to divide by 10. So 10 can be written like this also, 10 to the power 1. 10 to the power 1 is 1, and 10 to the power 1 is 10. 10 when divides 4, we get 0.4. Now for 0.04. For 0.04, 4 has to be divided by 100, and 100 is 10 to the power 2. 10 to the power 2 is 10 tens are 100. So 100 when divides 4, we get 0.04. Similarly, for this 0.004, 0.004, what we can do is we have to divide 4 by 10 to the power 3. When you divide 10 to the power 3, we get 0.004. We can also apply this particular process to solve our program. Now, if you look at this program carefully, what we will be doing is we will first, we do not need to store anything over here, okay? We do not need to use extra variable, because what we'll do is we'll directly print all these things. We'll directly print this. And to print this, what we have to do is, okay, now let me erase this. Okay, this is actually 10 to the power 3. So to do this, what we'll do is we'll be using print keyword. Pay attention. Then 4 is always fixed, so 4 is fixed. We'll write directly 4. Then division sign is there, we'll divide this. Then we have 10, we have, every time we have 10, so write 10. Then we'll use this exponentiation sign. Then after this, what we have to do is, here it has to be 0, then it has to be 1, then it has to be 2, then it has to be 3. Only this part is changing, rest is all fixed. So somehow we have to get this particular values from a variable, and we have to keep that variable over here so that we get our required output. So let's see in this editor, and it will be much more clear. Okay, so what, now this time we are not going to use this extra variable. What we'll do is we'll directly print over here. So what we'll do is we'll write 4 has to be divided by 10 exponentiation. Now at the beginning it has to be 0, then it has to be 1, then it has to be 2, then it has to be 3, then it has to be 4, 5, 6, so on. Okay, now according to our series, we have to generate how many terms? 1, 2, 3, 4, 5, 6 terms. And if we, now our start value is 1 over here. Now instead of 1, suppose I use 0 as my start value, then what should be my end value? That is the question to you.
Sir, 6. No, sir, 5.
Exactly, it has to be 5. Now if we write 6, then our loop will run 7 times, and that will be incorrect. Because we need to display 6 numbers, our loop has to run exactly 6 times. And this time we are starting our loop with 0. So when we start with 0 to run 6 times, it has to run go till 5, which you have already answered. So it will become like this. It will start from 0, then it will become 1, then 2, then 3, then 4, then 5, then 6. And once it becomes 6, loop will be invalid and it will terminate. So our loop has run this many times: 1, 2, 3, 4, 5, 6. So our start value has to be 0. We are starting with 0, hence our end value has to be 5. So here what we need is, we need 0, we need 1, then we need 2, we need 3, and so on. And all these numbers comes from variable I. So we can write I over here, and this is not required at all. So let's run our program. As you can see, our output now, everything is coming in a different line because we haven't kept semicolon. If we keep semicolon, then everything will come in the same line. So this is also another method of doing this particular program. Thank you so much for watching. Please do like my video so that I get motivated to create more of these videos. We would appreciate if you would share this video with your friends. And if you have any queries and suggestions, let me know through the comment section. Lastly, please do subscribe my channel and press the bell icon so that you get notified every time I post a new video. Thank you.